Okay, so now we're going to talk about pulleys, which is another form of simple machine. Before we get started, I just want to show you kind of what one looks like. That way, if you don't know what it looks like, at least you'll have an idea what we're talking about. So here's three different kinds of pulleys. Well, they're basically the same kind, but as you can see, they have this one has one slot for one rope to pass through it. This one has two slots, two actual pulleys, and this one actually has three. All right, and just to make sure that you're on the same page with me, what we're looking at is we have a pulley system, and this I'm just going to draw a quick rope here, just so you can see basically how this thing works. I'm just going to draw a quick drawing here. That this rope, it goes up and through it, and it comes back down, and it comes back down out of it. And this one has a rope that can go up through it, and it will come back down. And again, this can go up, and it'll come back down the other side, so on and so forth. So that even happens here. So you can put, as you can see, it goes up. And what these do is they allow you to apply mechanical advantage, really to lifting something, pulling something, and because they help with mechanical advantage, they actually will decrease the amount of effort needed to move an object, either to lift it or to move it. And they're actually very, very useful. A lot of people use them. They're actually very simple, very simple to figure out, very simple to use. And I'm gonna draw one right here. We're gonna draw. There's two different kinds. There's a fixed pulley. A fixed pulley, which looks like this, and we're just going to say that's the ceiling. Okay, and a fixed pulley, they call it fixed because it's actually fixed to the ceiling or to a non-movable object. That's the key, is the object that it's fixed to is not moving. So here's the pulley. All right, this is a fixed pulley, and what happens is, let's just say we have a box here that we're lifting up. Okay, we're gonna take our pulley. We're gonna run a rope. We're gonna run a rope up around the pulley and come back down. So here's our resistance right here. Resistance wants to get pulled down because of gravity. And what we're doing is, in this case, we're going to be pulling. Here's our effort right here. We're going to be pulling down on this. And the reason this is called a fix is because it's affixed to the ceiling. And what this is, what kind of mechanical advantage this gives us, is a mechanical advantage of 1, an IMA of 1. So it doesn't actually do anything in terms of helping us lift something with less weight. Let's say this is 100 pounds. Let's just say that's 100 pounds. Okay. That's 100 pounds. Well, we'd have to lift with 100 pounds. So why use it? Well, if you notice, if we have to lift this object up, in the air, well, let's say we can't lift it up in the air. We just don't have the access to. But we do have access to pull down. We can string a fixed pulley and lift it up by pulling down. So we pull down and the object goes up. So the point of a fixed pulley is it changes direction. I'm just going to write D Changes direction. Alright, that's the only thing it does for us. Only thing it does is change direction. Okay, so if we need something to go up, we can pull down. So that's a fixed pulley. And there's another one, and if that one's called fixed, this one is called a movable pulley. Movable, right? And the reason it's called a movable is because it moves with the object that you're moving. All right, the other one was fixed; it didn't move when you pulled on it. This one moves. This one moves with it. Okay, and just draw you a quick picture of it. Let's just say here's our ceiling again. Those lines, whenever you see those lines usually mean that it's attached to something. It's basically it's like concreted into something. All right, and do the same color so we're all on the same page here. Here's our pulley. All right, and here's our object. Here's our box of goodies. Okay, well that box of goodies is attached to the pulley, and our rope basically it gets attached to the ceiling, or it gets attached to a fixed object, and it goes around the pulley. Alright, and what happens is, as I pull up in that direction, this thing is also going to go up. Okay? But let's just say, again, that's 100 pounds. If that's 100 pounds, how many strings are supporting it? How many ropes are supporting it from it coming down? Well, there's one string, and there's two strings. Those two strings are directly holding this thing from falling down. So if this is 100 pounds, there's 100 pounds right there. That means that there's 50 here, and there's 50 there. Okay? So a movable pulley has an MA, a mechanical advantage, of 2. Has a mechanical advantage of 2. Because you look at the strings that are directly holding it up from it falling, holding the object up from falling. If you count them, there's 1, 2. Notice here, this is the only one that's holding it up. Only one that's holding it up. So there's 100 pounds right here. That string is holding 100 pounds. So this has an MA, mechanical advantage, of 1. Movables have a mechanical advantage of 2 because there's 2 strings for every pulley. Alright? Pretty simple. Pretty simple. Well, these are 2 simple sets right here. These are 2 simple sets. Alright? Let's just say that we have a larger set. Just say we have a larger set. And I have these 2 quick drawings here. Or I'm sorry, 4 little diagrams that we're going to look at. We're going to start to dissect. Okay? So we have a couple things we got to look at. Alright? So we're going to look at number 1 first. Well, how many strings? First, I want to find a couple things for each one of these. I want to find the IMA for each one. Okay? IMA for each one. And I also want to find the AMA. Actually, we'll stick with the IMA for right now, and we'll move on from there. Okay? Well, the IMA for a fixed pulley is 1. Okay? Or we can count the strings. So what I do, easiest way, is I draw a line through all the lines that are directly supporting our load. So right here is our load. It's 100 newtons being pulled down by gravity. I just drew a line through all the ropes that are directly holding it up. All right. So there's one string that's holding it up. So that means that the IMA is 1. Okay. And how much weight is on this string right here? Well, there's 100 pounds being pulled down, and our mechanical advantage is 1. There is 100 newtons. Right there. There's 100 newtons. Okay? Let's go a little bit farther. If we had to pick this up 10 centimeters, so our distance to resistance is 10 centimeters, how much are we going to have to pull? How much are we going to have to pull? Well, this distance we're going to have to pull because the mechanical advantage is 1. We're going to have to pull the same exact amount. So we're going to have to pull 10 centimeters. Okay? And if you don't really get where I got that, let's just take our IMA formula. IMA equals dE over dr. Well, we know what the IMA is. The IMA is 1. We also know what the distance to the resistance is. So let's just put that in there. We have an IMA of 1, and we have a distance to resistance of 10 centimeters. Well, how do we find dE? Well, we multiply both sides by 10. Multiply both sides by 10. And lo and behold, we get 10 centimeters One times 10 centimeters is 10 equals dE. So that's how we got that dE. Alright, I just kind of did it, kind of figured out, but that's how you actually do it. So let's go to the next one. So right here, again, I want to know the IMA. I want to know the IMA for this system. Well, we're going to draw our line right through all the strings that are directly supporting it. And notice, here's a quick tip. If the string that you're pulling on, if you're pulling down, you don't count it. All right? If you're pulling up, you count it. If you're pulling it down, you do not count that string. So right here we are pulling down, so we're not going to count it. We're going to count all the other ones. So we're going to do that, and all I do is I look at, okay, so I drew my line. How many times does that line hit a string? Well, it hits a string here, hits a string here. So that's 2. Well, I hope you're starting to see it. We have a fixed pulley right here. We have a fixed pulley. Fixed pulleys have a mechanical advantage of 1. That's hard to see. Sorry about that. Fixed pulleys have a mechanical advantage of 1. Movable pulley has a mechanical advantage of 2. Alright. So 1 times 2 is 2. But I really just like to count the strings. I think it's much easier. Okay? So we have an IMA of 2. Alright? Well, let's do a quick breakdown. If there's 100 pounds being pulled down and there's 2 strings supporting it, and the mechanical advantage is 2, because there's 2 strings, how much is on these strings? How much weight is on these actual strings, each one? Well, 100 divided by 2 is 50. There's 50 on each one. There's 50 newtons on each one of those. Okay? Let's go a little bit farther. let's find this distance. Let's find this DE again. Well, like we did up here, we know the mechanical advantage, the IMA, is 2. We don't know DE, but we know DR, which is 10 centimeters. Same problem. Alright, 10 times 2 is, hopefully you can figure that out without a calculator, means your DE is 20 centimeters. So that kind of represents what mechanical advantage is, isn't it? Well, we're lightening up our load. We're going to only have to pull with 50 newtons instead of 100. So we're lightening our load by 2. We're cutting it in half. But look how much farther we have to pull. We have to pull twice as much distance. We have to pull 20 centimeters instead of 10. So we're giving up distance to gain force. We're giving up the distance to gain the force. That is true mechanical advantage right there. Alright, so let's go to the next one. We're going to go a little bit faster now. IMA. Alright, and again, I just take my thing. We're still pulling down, so we're not going to draw a line through it. My line hits it 3 times. My line hits it 3 times. So the mechanical advantage of it is 3. Mechanical advantage is 3. Here's 100 pounds right here. 100 pounds, how much is on each one of these lines? If you look at it and you go through it, you do 100 divided by 3, you get 33. IMA is 3. We do 100 divided by 3, and we get, there's 33.3 newtons on each one of these strings, which means we only have to pull with 33.3 newtons of force. But again, because we only have to pull with 1/3 of the weight, guess what we give up? Well, we give up 3 times the distance. Give up 3 times the distance. So instead of pulling 10 meters, now we have to pull, that's right, 30 centimeters. Okay? Hopefully you're starting to see a pattern here. IMA. Hope you can get this one. They got our line. 4. There's 4 strings that are directly holding this thing, this weight, from falling down. And you do 100 divided by 4, and you get, 25 newtons. So we only have to pull with 25 newtons, but we have to pull 4 times the distance. We have to pull 40 centimeters. So we only have to pull 1/4 of the weight, but we have to pull it 4 times the distance. Okay, just to do the same, just to pick it up 10 centimeters. That 10 centimeters has never changed. The only thing that's changing is our pulley setup. Okay, so you want to count the number of strings. Draw your line through all the strings that are directly holding it up. That's the key. Directly holding up the weight from falling down. Alright? And a tip, again, hint, is to make sure that if you're pulling down, if the effort is pulling down, you don't count that string. If the effort is pulling up, you count that string. Okay? Alright? Well, I hope that helps, and that's pulleys.